Hey there, so you decided to look at the next set of examples of solving exponential equations. Very good. So, by the way, at any time, if you're like, hey, I got that problem, like say for instance, you got problem number 1 and you need to see problem number 2, fast forward. Nobody says you have to watch number 1 to see number 2. Cool? Okay, so let's get to number 1. So talk to me. What are we doing? We're solving for x. Very good. Where's the x located? In the parentheses. And I have something outside the parentheses, don't I? So to get to the inside of the parentheses, you first need to get rid of what's on the outside. So divide both sides by 5. I agree. 5's cancel. Tell me what remains. 2 to the power of 3x equals 8/5. Very good. Cool? Okay. Now what? You're right, you can't turn an 8/5 into a base 2. The 8, but not the 8 over 5. So, log base 2 of both sides, got it. Let me write that down. Let me catch up with you guys because you guys already worked on this problem. And now your next line, 3x equals log base 2 of 8 over 5. Very good. Then what? And then divide by 3. And here's where your problems, or your answers, I should say, start to look a little wonky. You're like, that's a crazy looking answer. And they said to give them an exact answer. So that's what I'm going to do. I am going to give them an exact answer and not worry about how interesting the answer looks. And then if they want a decimal, I'll have to punch that in. But they said an exact answer, so there you go. Cool? Excellent. Okay, so talk to me about number 2. How'd you do on number 2? Similar to problem 1 in that you need to get to the parentheses or inside the parentheses. So get rid of what's outside the parentheses. Tell me how you did that. You divide both sides by 0.3. Understood. So what's your next line look like? 4 to the 0.2x equals. Now, this you can simplify without a calculator. Because technically that's 2 over 10 divided by 3 over 10, right? So if I do 2/10 and I multiply by 10, numerator and denominator, what's that going to become? That's just going to become a 2 on top and a 3 on the bottom. Yes. So 2/10 divided by 3/10 is simply 2/3. Why? Because I multiplied top and bottom by 10. And if you don't believe me, take your calculator out and multiply it. But trust me, I know what I'm doing. Good? Okay, now what? Log base 4 on both sides. Because I need to get to the x, which means I need to get rid of the base. Understood. And now it looks like 0.2x equals log base 4 of 2 over 3. And then divide by the 2/10, right? Okay. So x equals log base 4 of 2/3, the whole thing divided by 2/10. And now I'm not going to multiply top and bottom by 10 because the numerator doesn't have a decimal like it did in the first line, so I'm not going to worry about trying to simplify that. Cool? Okay. Got a few more examples coming your way, so stay tuned. Hey there. So how'd you do with these two? Oh, they are a little different, aren't they? Only because both bases have a power to them. So you're like, well, now what do I do? Well, remember, this is still an exponential equation. So to solve it, you need to take the log to get rid of the exponential. And you're like, yeah, but which base? I have a base 3 I could use or a base 4 I could use. You're right. The choice is yours, which base to use when you're taking the log of both sides. When you're asked for an exact answer, If one of you chooses log base 3 on both sides and the other one solves by taking log base 4 on both sides, your answers are going to look different at the end, but when you punch them into the calculator, you'll get the exact same decimal. So just trust yourselves. Me personally, I always get rid of the base that's got more stuff going on in the power. So in this case, I would take the log base 3 of both sides, only because there's more terms in its power than on the other side. Good? Okay, so now, the next line simply is going to be 1 minus 2x. Agreed? Equals log base 3 of 4 to the power of x. Okay, so you're like, yeah, but the right side still has the x in the power position. You're right, it does. But there's a log here, correct? So remember a property of logs? What does it allow me to do as long as there's a log? It allows me to take the power and bring it down to the front. So that means we have x times log base 3 of 4. Good? Okay, wonderful. And then you're like, I have no idea. You know what's bugging you? This log base 3 of 4. Tell me, forget the x for a moment. Log base 3 of 4, is that a variable or is that a number? You're right, it's just a number. I have a number being multiplied by x, don't I? So let me sidetrack you. What happens if the equation looked like 1 minus 2x equals 5x? What would you do then? You would add the 2x to both sides. Okay, so you would have the 5x plus 2x. Agreed? So don't treat this one any differently. I need the x's on the same side. So add the 2x to both sides. Okay, so I have 1 equals log base 3 of x times log base 3 of 4 plus 2x. I agree. Okay? You're like, now what? Now what? You would add, right? You would add what? The 5 and the 2 and you would get 7. I'm in agreement with that. If I could propose, what you're doing over here is you're kind of factoring out that x and looking at 5 plus 2, which is how you got 7x. What do you think? Does that sound reasonable, logical? Isn't that what you kind of did? You just said 5 plus 2 and then brought the x with it? So over here, factor out the x. Right. 1 equals x times a quantity, log base 3 of 4 plus 2. And now it's a little more obvious. To solve for the x, you got to divide both sides by that parenthesis. Agreed? Just like you would divide both sides by the 7 over here. So you have 1 over log base 3 of 4 plus 2 equaling x. And that's a not so nice looking 3, is it? Let me fix that for us. Okay, so log base 3 of 4. Good? You with me? Not too bad, right? Here's the key. Me personally, when I get stuck with things that look like this, in my brain, if I can just understand what the log base 3 of 4 actually represents, it's just a number, then I'm going to give myself a problem exactly like this, except put in any old number for the log base 3 of 4, so I can at least figure this problem out by doing one I already know. Good? Okay, so talk to me then about number 4. What are you going to do on number 4? Well, you're like, they both have 2 terms in the exponent. You're right, they both have 2 terms in the exponent. So does it really matter which one you're going to get rid of? No, not really. So let's see. Which one do you guys want to get rid of? I heard some of you say get the base 2 gone. That's fine. Most of you probably got rid of the base 2 because it's on the left. I'm okay with that. So I'm going to take log base 2 on both sides And so my next line looks like x plus 1 equals log base 2 of 5 to the 1 minus 2x power. Very good. Now what? Similar to this one, where I still had the variable in the exponent position, but thanks to the property of logs, I'm allowed to bring it in front and multiply. Okay, so let's do that. So we have x plus 1 equals 1 minus 2x times log base 2 of 5. Very good. Now what? Like, I'm not sure. Okay, let's stay focused. Forget this parenthesis. What's log base 2 of 5 represent? You're right, it represents just a number. So how about I give us x plus 1 equals, in parentheses, 1 minus 2x times 7? Okay, I don't think it really mattered, right? So if this was the problem you had, what would you do next? You would distribute that 7, wouldn't you? You would have x plus 1 equals 7 minus 14x. Agreed? All right. So what about over here then? Distribute. So we'll have x plus 1 equals log base 2 of 5, because you're doing it times 1, and then minus 2x times log base 2 of 5. Got it. Well, that's rather lovely looking, isn't it? Now what? What would you do over here? X is on the same side. Okay, so tell me over here what you would do. Some of you would add the 14 to both sides, the 14x to both sides, because you're used to having your x's on the left. And let's keep them positive while we're at it. All right. So then over here, add the 2x log base 2 of 5 to both sides. So we have x plus 2x log base 2 of 5 plus that 1 equals log base 2 of 5. Got it. So all my x's are on the same side, right? What would you do over here? You would subtract the 1 over. So you'd have x plus 14x equals 7 minus 1. Understood. What would you do over here? Minus the 1 on both sides. Very good. So talk to me. Tell me. X plus 2x times log base 2 of 5 equals log base 2 of 5 minus 1. Excellent. Very good. Quick question. Can you subtract the 5 and the 1? Good, you can't, because this is a single number. And sometimes putting parentheses around helps. All right. So now what? Go back to this problem. What would you do over here? You're right. You would add the 1 and the 14, right? So technically, you're factoring out that x, so you can add the 1 and the 14. And I'm just going to make this a 6 over here. So what would you do over here? You'd factor out that x. So we would have x times the quantity 1 plus log base 2 of 5 equals log base 2 of 5 minus 1. And then last but not least, good. You're going to divide both sides by the parentheses, aren't you? So when I do that, we end up with x equaling log base, you know what? I'm going to give myself just a little bit more room. And instead of writing it there, I'm going to put it over here. So we end up with x equals log base 2 of 5 minus 1 divided by this parenthesis, 1 plus log base 2 of 5. Well, that's a lovely looking answer. And if at the beginning you took log base 5 on both sides, that answer and this answer won't look the same. However, if you got their decimal versions, they would be exactly the same. Good? So to recap on both of these problems, you have to choose a base. I like to choose the base that has the more terms than the exponent. This one was obvious. I chose base 3. This one, not so obvious, so take your pick. The point is understanding your algebraic solving techniques to get the x by itself. And again, just like I did before, when I have something that looks a little bit wonky, shall I say, it's like, well, what the heck do I do here? Well, what would I have done here? Get this log base 2 of 5, since it's all numbers, that's just a number, and substitute a different number in place for it. Cool? Okay, I have one more example coming your way. If you haven't done it yet, work on it first, and then go look at the answer. Stay tuned. Okay, did you try this one before you found or you continued the answer key video? You did? Good. Tell me what you did first. Haha, you took log base 7 of both sides. I agree, because the 7 has more terms in its exponent than the than the left side does. Okay, understood. What's your next line look like? Log base 7 of 3/5 to the power of x equaling 1 minus x. Good. By the way, do you know why you keep the parentheses around the 3/5? Some of you do, some of you don't. Let me do this, just to make certain you understand why the parentheses are there. This x, it's the power of what? The whole fraction. If you write it like this, without the parentheses, then it's automatically assumed that the x sits on the 3. So it's the power of just the 3. Whereas here, since there's parentheses around the entire fraction, that x sits on the parentheses, which means it sits on the entire fraction of 3/5. So the parentheses are extremely important to have, so don't ignore them, okay? Okay, that was a little side note, just making sure everybody's good with that. All right, now what? Bring this x in front, understood. And then what'd you do? You're like, the log base 7 of the fraction 3/5 is just a number, and there's an x multiplied by a number. Need your x's on the same side. So you added x to both sides. Okay, got it. So we have x times this number, even though we don't like the way the number looks. And we added x, and that equals 1. Then what? Very good, you factored out the x. So x times a quantity of this number plus 1 equals 1. And then divide both sides by that lovely set of parentheses. So 1 divided by log base 7 of 3/5 plus 1. Very good, guys. Excellent. You're getting the hang. You're getting the hang of it. You're getting your brain trained to understand that when you have log base 7 of a number or log base a number of a number, this is just a number. It's not a very nice number in terms of what we're used to seeing. We're used to seeing a decimal, a fraction, an integer, but we're not used to seeing it like this. But it's still a number, so you're getting used to it. That's good. Okay, so I have another set of examples that if you'd like to get a little more practice, or at least take a look at them, because some of them you're like, oh, I know how to do those, but wait, those other two I'm not so sure about. You know, you can pick and choose. But regardless, make sure you try them before you find my answer key video. Have fun, guys. Catch you on the flip side.